All right, here we go. Get out your graphing calculators. Okay. Average value of a function. Y equals x cubed, the square root of x squared plus 2x plus 1 from 0 to 4. How do we find the average value of that function? Put it into the calculator. Absolutely. So I'm gonna mess with my screen a little bit. There we go. And there. All right. So, graphing calculator. Y equals. Clear out what's in there. X cubed. The square root of x squared plus 2x plus 1. We graph it. Now what do? Bella? What do? Second trace 7 from 0 to 4 is 268.8. So 268.8 divided by 4 is 67.2. And that's the average value of the function. Okay? If it wanted in terms of a fraction, it would be 336 over 5. Okay? Yes.
Just to clear up, you're dividing by 4 because it's 4 and 0, right? So if
Right.
it's 4 and 2, then you would divide by 2 instead.
Right.
Yes.
All right.
Turn up.
The next one. We didn't do a lot of these in the chapter, so make sure you pay attention to this one. No. Okay. If the acceleration is negative 2t and at time 0, the velocity is 20 and the position is 18, what is the position at 2? What do we do first? You integrate a sub t. So that's the integral of negative 2t, which is negative t squared plus c. That's the velocity function. Well, the velocity equals negative t squared plus c. So the velocity is 20 meters per second when the time equals 0. So what is our velocity function going to be? Negative t squared plus 20. But we're looking for position, aren't we? So what do we do to find position? Integrate again. So the integral of negative t squared plus 20, which is negative 1/3 t to the third plus 20t. Yeah, this is 20 there, Mr. Ricky. Plus c. Okay, that is a position function. Now, what's c going to be if I plug in a 0? 18. So our position of t equals negative 1/3 t cubed plus 20t plus 18. Now, how do I find my position at time equals 2 seconds? Plug in 2. Find s of 2. Negative 1/3 times 2 cubed plus 20 times 2 plus 18. Well, this is negative 8/3 plus 40 plus 18. 8/3 is 3 2/3. So 58 minus 2 2/3 would be 55 1/3, or 166/3, right? Yes, Trey.
When you're finding your C, why do you plug in a 0? Is that
Because at time equals 0. So if time equals 0, t is time. So you plug 0 in here, 0 in here.
I'm just making sure.
Mm-hmm.
Here's when do you integrate it twice and when do you not?
If it's acceleration and we got to go all the way position, it's twice, because we have to go from acceleration to velocity, then to position. Distance is part of position. It's the change of positions.
What's the one where you have to take the absolute values?
That's distance. That's the absolute value of displacement. Displacement is how far you went, basically back and forth, and distance is the absolute value of that. All right, here's a velocity versus time graph. How can you figure out the total distance traveled here? This is ridiculously easy.
6 minus 0. Just figure it out underneath the graph.
Yeah, figure it out underneath the graph.
No, it's not.
So there's 1, 2, 3, 4, 5, 6, 7 and a half make 8 and a half. Missed that other half. Okay? Is that very difficult?
Is it for sure gonna say velocity?
No, that wouldn't be the same. So, because the integral of velocity is position, and position tells you the total distance traveled. So, there we go. Oil is leaking from a tank at a rate of R sub t equals 6 minus the square root of t gallons per hour. How much leaked from the tank from time equals 0 to time equals 9 hours? Put it in the calculator. Because you're integrating from 0 to 9 of 6 minus t to the 1/2 power. Now, if Alex was here, he would write this out. If Alex was here, he'd write it out. So this is 6t minus 2/3 of t to the 3/2 power. And then you'd stick in a 9 and you get 54 minus, this is 27 times 2, which is 54/3, right? Which is 162 minus 54 is 108/3. Okay, I'm just guessing there. We'll see what the calculator says. But I think my guess is probably pretty close. So 6 minus the square root of t, graph it. Second trace, 7, 0 to 9 is, 36, it says. Oh, okay. So we're at 36. But if the answers, it's multiple choice, so I would have gotten to there. Yeah. Find the area of the region enclosed by the graphs y equals 1/2 x and y equals x squared minus 4. How do we do this? Well, y equals 1/2 x is a graph going like this through the origin. Okay? Y equals x squared minus 4 is a graph that looks like this. How do we find the area of that region enclosed by them? So graph them both. Yeah, you do. 0.5x and x squared minus 4. Graph them both. So we got to find out where they intersect. So second trace intersect number 5. And you go over to this intersection point and press enter, enter, enter. And it's at negative 1.765564. Put all those decimals in. And then you go second trace 5 intersect. And then go to the right intersection. And then go enter, enter, enter. And it's 2.2655644. Okay? And then, what's my top curve? The 1/2 x or the x squared minus 4? 1/2 x. So that's what I need. So my 1/2 x, I'm going to turn off that one. And turn off the second one. And then do I go y2 minus y1 or y1 minus y2? It'd be y1 minus y2. Do you understand why it's y1 minus y2? Because y1's on top. Graph. So it goes like that. And you go second trace. And then 7 from negative 1.765564 to 2.2655644. And it's 10.92. And it'll be multiple choice, so it should be all right. You should figure it out once you guys put your 4 to 5 brains together. Okay? What about this one? Same thing. Let's do it quick. X squared plus 3x plus 5. The other one is 4 minus 2x minus x squared. Whoa. Try that again. 4 minus 2x minus x squared. And then I'll shut off this extra one. Graph it. And it should make loops like that. So, what's my next step? Second trace intersect 5. Got to find their intersection points. So go close and go enter, enter, enter. Negative 2.280776. Second trace 5. Enter, enter, enter. Negative 0.2192236. So, which one's on top? Y1 or Y2? So you go Y equals, and then you want to turn off that one. turn off that one, turn off that one, turn on that one, graph. And go second, trace, negative 2.280776. Whoops. Second, trace 7. That's the lower limit. Negative 0.2192236 is the upper limit. And you get 2.92. So you'll have a bunch of areas under the curve problems, in between the two curves problems. Okay? A bunch of those. Okay? Now, it'll say what?
How many questions is it?
Like 16. Find the integrals of the areas enclosed by the two functions. So, how do we find this area and how do we find this area? Using integrals. So they're two separate integrals that we do what with? Add them together. So it's the integral from 1 to 5 of what? G of x minus f of x. And then we add on the integral from 5 to 9 of f of x minus g of x. This isn't even hard, is it, Enoch?
In theory, no.
No.
I always somehow manage to mess it up.
Oh, that's it?
Yeah, that's all you have to do for that problem. Because there's no other numbers in. You don't have the functions. You just...
So what are you trying to find, the area?
The area in between the two curves. So you...
I get it, I just didn't know.
All right.
Wait,
So we will... Yes, Trey.
Sorry. Why exactly do you go from gx minus fx to fx? Because it's on top.
G is the black one. It's on top from 1 to 5. And then F from 5 to 9 is on top. No, I'm not trying to be sarcastic. I'm trying to be crystal clear.
And I also started by missing. Oh, yeah.
Okay, now for the ones that some of you have some issues with. A solid is in the first quadrant, bounded by both x and y axis, and the graph y equals 4 minus x. What's the volume of the solid if each cross section perpendicular to the x-axis is a square? All right, we should draw this. There, there, and 4 minus x looks like that, right? What are its intersection points with each axis? 0, 0, 4 here. Thank you. And 4, 0 here. And you're perpendicular to the x-axis. So you've got a square that looks like this, and a smaller square that looks like this, and an itty-bitty square that looks like that. Okay? So how do you find this? Okay? As you work from here to here. Well, it's the integral from where to where? 0 to 4 of the function 4 minus x. That's the width of it. What's the height of it? 4 minus x, so it's 4 minus x squared. Because it's a square. And to find the area of a square, you take the side squared. Dx. I'm not being a smartass. I'm just talking slow so you understand. All right. Then, what else do we do? Integrate. So on our calculator, y equals, clear, clear. Turn this off and go back up to y1. Parentheses, 4 minus x quantity squared. Graph it. And then you go second trace 7 from 0 to 4. And it's 21 and 1/3. And if you say, well, let me have that in a fraction, please, it's 64 thirds.
That's pretty neat.
Everybody good with that?
Is it gonna always be a square or is it gonna be a differential?
If it's a square, then it's a square.
Of what? That's my favorite part.
The semicircle.
All right. So Nate, Ricky, how would you do this one? What are we talking about here?
Talking about solids and volume.
Yeah.
I just had to check an email from my teacher.
Uh-huh.
Graph it.
Graph it.
I
Okay.
was listening to the last one. I just had to check.
Perpendicular to the x-axis is a semicircle. A semicircle looks like this.
That's a weird semicircle.
Well, I can't help that part of my screen is kind of broken. Well, maybe I could help it if I wouldn't have broken it, but whatever. All right. Now what?
Now we do the integrals. We do the integrals.
The area of a semicircle.
1/2
1/2 pi r squared. So what's the radius of this semicircle right here? It's 1/2 of 4 minus x, or it's 4 minus x over 2.
Square.
Not quite yet. So we're going to integrate from where to where?
From
0 to 4, because that's where our intersection point is here. And then we're going to go 1/2 pi, so I'll go out front 1/2 pi, and then the radius squared, 4 minus x over 2 squared. Okay? See where we get all those numbers from.
Yes.
Trey, you can ask. I'm not going to yell at you.
I know where I'm going.
Okay? So I'm going to leave this 1/2 pi off for now. So I'm going to go y equals, I'm going to take this and go divided by 2, parentheses, and insert a parenthesis up front, squared. Okay, we good with that?
Yes.
So we're going to graph that. It's going to look like that. And we're going to go second trace 7. And again, from 0 to 4. And it's 5 1/3. And then we're going to multiply that times 0.5. And we get that. And if we go math, turn that into a fraction, please. It's 8 pi over 3.
So you're just using calculate to find the area, right?
Calc 7, the integral. What?
I could have been doing this the whole time.
Yeah, con was a little harder than this. But if we do con enough, it really helps you for AP. Okay. Let R be the region in the first quadrant bounded by the x and y axes, the horizontal line y equals 2, and the graph y equals the square root of x minus 2. What is the volume of the solid generated when R is revolved about the y-axis? So what I'm going to do here is I'm just going to help you clue in on this and graph the square root of x minus 2. Well, actually, we're going around the y-axis, right? So we put it in terms of x. So if y equals the square root of x minus 2, then y squared equals x minus 2, then y squared minus 2 plus 2 equals x. That's what I want to graph, right? Okay. Nate, what's so interesting on Aspen's computer?
The AP Calc exam info 2022.
Okay.
But this is.
Wait, why do you wanna flip it around like that?
Because you're revolving around the y-axis. When you revolve around the y-axis, you got to solve for x. All right. So what happens here is the graph looks kind of like this. I'll just x squared, x minus 2. I still want to graph still going to graph it this way, just so you, whoops. I'm still going to graph this one, second square root of x minus 2 graph. So the graph looks like this, and you're going until you hit the line y equals 2. So it's this is going to be revolved around the y-axis here. Got that? So, but I'm not going to use this when I integrate. I'm going to use this because the calculator can't handle this. Okay, Desmos good, but calculator doesn't, and I know how to use a calculator, not Desmos, very well. So we're going to say x squared plus 2. We're going to graph this. Okay? And we're going to go from 0 to 2. So second trace 7. Oh, nope. I'm not ready yet, am I? I got to integrate from where to where? 0 to 2 of what? Pi, disk method, r squared. I got to square that bad boy. So go to y equals and insert parentheses around this. And square it. Okay? So then, second trace 7. Let it graph. I'll go from 0 to 2. And it's that. And then if I ask the computer, please put it into a fraction, it does. And so it's 376 pi over 15. X instead of y. But yep.
How did you know from 0 to 2?
Because I have a horizontal line at 2. And then the other one is just 0, yep. Because it's bounded by the x and y axes. So 0 here and here.
Will it be that same way?
Should be. Okay. Is this the last one? Not quite, no. What is the volume of the solid generated by the region in the first quadrant, bounded by the graph y equals 4x? So 4x is one going kind of up like that. The x-axis and the vertical line x equals 6. So vertical line x equals 6 kind of comes together there. X-axis we're doing this, and we're revolving around the x-axis. So it's the integral from where to where? 0 to 6. So it's going to be a pretty big number, I have a feeling, of 4x squared with a pi in front. Yeah, pi r squared, because we're revolving, so we're making a circle. So that's pi r squared. So we're going to clear that. Parentheses, 4x, parentheses, squared, graph. And that line will go way up and go second trace 7 from 0 to 6. And it's a big number, 1152 pi. Okay. So both those were what method? Disk method. I bet the washer method comes up here pretty soon. What's the volume of solid generated by the region bounded by y equals 2x, the horizontal line y equals 4, y-axis revolve about the horizontal line y equals 4. Okay, so y equals 2x is a line going up like this. The line y equals 4 is here. We're revolving around this. So, disk or washer? Still disk. Still disk, because this is up against this. It's up against the line that we're revolving around. We're just not revolving around the x-axis or y-axis. Okay? So it's the washer method. Or disk method. So it's the integral from where to where? Okay. Because we're revolving around a horizontal line. Where's this point? Right here. Do we need to graph it to figure it out? With the silence.
Yeah.
Even I'm not hearing total silence because some people are saying answers up front, but silence back there. I better graph this. The line y equals 4 and y equals 2x. If we graph them, we get that. Second trace intersect, which is 5. Zoom. Zoom on over. Hey, there's Aspen. Enter, enter, enter. So this happens at the point 2, 4. So how do we set up our integral? Integral from 0 to 2. Pi r squared. How do we figure out our radius? 4 minus 2x. Excellent. Why is it 4 minus 2x, Aspen? You just trusted your partners on this, or what? You're at 4 here. How far is it from 4 down to 0? It's going to be 4, right? So if you put in a 0, it's going to be 4. At 1, this is a point 1, 2, correct? So how far is this? Well, it's 4 minus 2 times 1, or 4 minus 2. This is too long. When you get up to 1.9, how long is it? Well, it's 4 minus 3.8, okay, which is 0.02. This looks really short, like 0.02, right? Or 0.2. So that's how you do it, okay? So y equals, clear, clear. So we're going to graph 4 minus 2x. squared. Second trace, 7. It'll graph it for us. Go 0 to 2 is 10.67. Math, turn it into a fraction, please. So it's 32 pi over 3. We good with that? Okay. Let S be the region enclosed by the graphs y equals x. That's this line right here. Y equals x squared. That's a parabola here. And the line x equals 4, y equals 4. Now, where did these two intersect at? They intersect at 1, 1, right? They intersect down here at 0, 0. We're going to revolve around the line y equals 4. So it's going to be the what method? Washer method. Okay? Because there's going to be a hole in this. Okay? Because 1, 1 isn't all the way up at 4. This is kind of deceiving. This line should be way up here somewhere. Okay? Quite a bit higher than that, but whatever. Okay? So, when you do the washer method is pi integral the long radius minus the short radius. Okay? What's my long radius? 4 minus the bottom one, x squared, minus the short radius of 4 minus x squared. Okay?
How do you know from 1 to 0? Where did you get those 0, 0, or 1?
Because that's where they're going to intersect. If you graph and trace, I just know that because if 0, 0, 0, 0 for each of these, and then 1, 1, 1, 1 for each of these. Okay? So, if we graph them, y equals, clear, 4 minus x squared minus 4 minus x squared. Graph. Second trace 0 to 1. Oops. Second trace 7 from 0 to 1. Fills in that little thing. It's 1.2. If we go math, turn into a fraction, please. It's 6 pi over 5. Is the volume of the metal used to make our washer. Or plastic or silicone, whatever it's made out of. Okay? That's it.
So it's 4 minus x squared because the 4 is on top.
4 is way up here on this line, up here.
But
So the distance to here minus the distance to here gives me the distance in between. And that's what we're looking for, is how much distance is in between.
that makes sense.
All right. So that's the washer method. All right. So you've got your groups. You're taking it Wednesday. Now, some of you aren't done with the test yet. Some of you are done, but you might not have as high of a grade as what you want. So that's that. Plus, I'm handing out a packet today.
Thanks, Doc. Your graciousness will be remembered later down the line.